This is the continuation of our previous videos. In the last video, I showed you how to read some of the properties of the ICODE, the SLIX tag, and in this video I'm going to show you how to do the various other operations. In fact, you're going to learn everything about a particular ICODE tag, that is the ICODE SLI. So in my earlier videos I showed you where to buy these type of tags, and I did mention that these tags are the SLIX. In fact, this is not SLIX, it is just SLI. There is a bit of a difference between these two types of tags, and this is the documentation of the tag which I'll be using here. And because I'm new to this ICODE tags as well, I still have to understand the various types of ICODE tags. In this tag, so this tag doesn't have any password. So if you go through this documentation, this has got the 1024 bits which are organized as 32 blocks, and each block is 4 byte, and it also has got features like the electronic article surveillance, the AFI, the DSFID, and it also got a mechanism where every block of memory can be locked, and you can also lock the DSFID, AFI and EAS. If you compare this with this document, this is the one for SLIX. Now here the documentation says this has got everything from the first generation. The documentation refers this tag, the SL2ICS20, as a first generation ICODE tag, and this is the third generation, and this has got everything, plus it has got the password protection. So the AFI and the EAS can be password protected. So otherwise, whatever you have got in this first generation tag is also present here. So I'm not going to explain this. I'm not going to show hands-on on this because at present I don't have any SLIX tag. However, it's a very interesting tag to start with because it has less features, and you can understand all the important features of a ICODE tag. Now we have seen a little bit of this software in the previous video, so I'm going to activate. The activation will give you the 7 byte of UID. Sorry, this is 8 byte of UID, and we have seen how to decode this UID, and you can get the AFI, you can get the DSFID, and you can get the EAS, and you can also get the memory. And we also seen what are the various commands from the Omnikey reader writer that are used here. So if you don't have this software, you will learn the commands you're going to use, and if you already have this this learning kit, this feature is available in version 1.5. Now if you have worked with the other tags like MeFair, Ultralight, this is very similar to that. So I'm going to read the entire memory of this tag. Now the documentation says this has got 32 bytes. See, out of 32, the 4 blocks are reserved for storing the UID, the DSID, the AFI and the EAS and the lock bits. The remaining 28 blocks are meant for the user data. Now here I'm showing you the 28 blocks. The number starts from 0 and each block has got 4 bytes, B0, B1, B2, B3, and each block also has got a locked feature as well, so you can individually lock. So this is what the screen is. If you look at the various commands that are used, this is just a standard PCSC, the read binary command. Even if you want to read the data from the ISO compatible tags, it's the same command you'll be using. We have seen these commands used in the other tags like the DSFID or ultralight, or ultralight C and so on. So this is the command to read a block. So I'm reading the block, and this is the block number. You just have to look at the structure of this command in the Omnikey documentation, which I'm going to show you soon. So what I'm doing here is, for every block I'm using two commands. The first command is to read the data, and the second command is used to read the value of the locked bit. So which you can see here, the value of the locked bit is 00. Again, I'm going to show in the documentation how to decode this value. Similarly, if you look at this second example, you've got a block 1 followed by this block 1. The first command is to read the 4 bytes, or read the entire block, and we are reading only single block. And the next command is to read the security. It is called the security status, so we'll use the same terminology here. And the command for getting security status also looks like it's pretty longer than the command here. So I've got a section for locking. So if you want to lock any page, you can put a tick here and update it. Now let's go and try some of the simple read and the write operations. So I want to modify. I already got some data here, so I'm going to modify this with the, if I go with the ASCII, so I'm going to say Omnikey. So you can directly edit in the grid. So Omnikey, and I'm going to have a space. So I have modified the first two blocks to write. If you hit this the W link, the write operation takes place. Again, this is a standard the binary update command, and where we are updating the 4 bytes. And it's obvious that somewhere in the command you will have the block address. So that is these 2 bytes where the block address is stored. So I'm going to write the next block as well. Now if you want to read, if you want to check, so I'm sure that the write is successful because look at the return value, it's 9000, so that shows it is a successful write. However, you can, I'm going to take over this tag from the magnetic field, place it and choose this tag again. Now what I've done here is, before you click on a read tag, it's only for the users who are using the software. So you have to first get the memory size, because programmatically, so I'm taking this number and issuing the various and series of the memory or read binary command. And if you hit that, now you can see that there's so many read operations or read binary command has been sent. So you can also, so you can these things we have seen, how to get all AFIs and other stuff. And so this is how you read and write. Now I'm going to show you next how to lock a block. Now to lock a block, and keep in mind the lock operation is one direction. That means if you lock a block, that is locked forever. This is very similar to the way the locking is done in ultralight tags. So you have to be careful. Usually you would lock the block only after you have finished writing the data into the memory block. The data could be the raw data, what I'm doing here, or the data could be a NDEF record, so which is a higher level data structure. So once you finish the write operation, you would like to lock the block. The way you do that, again, very simple. See, the Omnikey 5421 reader writer, they make this using the ISO15693 tag so easy. You do not have to remember all the various commands we have seen so far. But however, for a developer like us, we want to know. So I'm going to spend another video explaining mapping how these simple operations to the actual command. Now assume that I'm happy with the data I've got in the first 4 pages. So you don't have to lock 4 pages. Probably I'm going to try with the very first. Put a tick and say update. Now something, I could see some flashing here. If you go down, now this is the command to lock the block, and I'm going to show this command structure soon. And I know this is a successful command because of the 9000. Now after this, if you want to write something, so I'll try to change this data to say 41424344 and hit a write. Now the write is unsuccessful. Now this is something different. If you have worked with the ultralight, or in fact some tags, they might tell you that when you lock a block, the lock will be effective in the next activation, whereas in this case, in case of this ICODE tags, the lock is effective immediately after the block is locked. Now if you try to write, you get this error bug. This 6282, again, this is a very standard ISO error code, and in fact the Omnikey documentation also explains what is this. So if you are not interested to know a very specific error, anything that is not 9000 is an error. So that's how so 9000 is a success, anything else is an error. Probably when you do a software, you will have a series of lookup values for these codes. You can say 6282, probably it could mean not enough access rights or invalid block or something like that. Now the good thing about these tags are, if you compare this with the MeFair, if there is an error, you don't have to reactivate. You take the tag out or place it back. You don't have to do that. So you can still continue with other operations. I'm going to write few more bytes here. Now I'm going to write, go to ASCII mode and write this as so here I know that there's something probably this is a feature not done right here, because I know the write is not successful. However, these values are wrong. So if you read again, you got the value back. Okay, so there's something probably I have to make some changes here. So what we just saw is we tried to write to a locked block, we got an error message, then we read the block, we got the original value back. So I'm going to I'm going to lock some more bytes here, some more blocks here, sorry. So change this as just stick with the hello world. Space. Okay, so I'm going to write this page 3 and page 4, and I'm happy with this, and I'm going to lock all these, the first 5 blocks, or the pages block 0 to block 4. Now if you look at what's happening in the from the command side, when I hit this button update, now here I'm sending a separate lock as a separate command to lock individual block. Now there is no single command to lock multiple blocks. Now if you look at here, because all these blocks were ticked, when you hit the update button, so the software sends a lock command for everything that is ticked. However, the block 0 was already locked, and look at, see what exactly happened here. Now if you try to lock again, you will end up getting the same 6282. So you cannot lock, there's no point in locking a lock block. Okay, so probably when you do the programming, you don't have to try to lock it if the block is already locked, which I'm going to show you how it's done here as well. Now if you look at this, the remaining 4 commands, these commands are for locking the block 1, 2, 3 and 4. Now it's very easy. You got plenty of memory here, you can put whatever data you want, then you can lock all the blocks. Now I'm just going to show you now what these buttons do. So if you don't want, if you want to remove all these new text, or if you want to show the current value of the blocks here, just hit a refresh. Now there is no read command, there's nothing, no commands are sent to the reader data. It is just syncing the grid with this tick boxes. Now I also have this button here, and keep in mind, this software is meant for as a learning kit, so it's showing all the things you can do with Omnikey. Now if I hit this button read, it's literally reading the log of all the 28 blocks. So you'll end up seeing a series of 28 commands, and you can see that when you try to read get status, because I know block 0 is locked, the value is 01. Likewise for block 1 the value is 01, whereas if you look at from block 6 onwards or block 5 onwards, okay, you got all these values are 00. So it's very straightforward. So like you can lock the blocks, you can also lock the AFI. Now the question is, why would you lock AFI? Now if you don't lock, somebody can manipulate the tag, somebody can. So the main purpose of AFI is to differentiate between different types of tags. Some tags may be of type for transportation, some tags with a specific AFI could be for accessing your canteen, or some could be for your library, and so on and so forth. Now again, it's very simple. It's very easy to use these ISO tags using this Omnikey reader data. The only drawback I would say is these readers are they're on the higher side cost wise. So otherwise these are the best readers. Now I'm going to lock, assume that we have decided, so I'm going to change this AFI to 68. I'm going to first set it. Now this is the command we have seen in the previous videos, and you got the response 9000. That's fine, and I'm going to lock it. So now the AFI has been locked. Again, there is a different command for locking AFI, and you got a success command. If you try to change something to something, now this should in theory should give an error, Now obviously you got an error. Now look at that, you got 6280. So get the value back, got 82. So likewise I can also log the value of DSFID. Again the question is, why would you log DSFID? Because DSFID can be used to know what type of data that are stored in the tag, and it's mainly for the developers. Once you use these tags to build a system, probably you might have a tag that stores NDEF data, or some tag could store a raw data or anything. Okay, this is just a byte which is available for us, for the developers, and we can do put whatever we want. And once you have set this data storage, I'm going to set this as a 21. I can set it, and after that, okay, there's again we have seen this put data command, and I'm going to lock it. That's locked. If you try to set again with a different value, you will get error message. Likewise, this tag, the ICODE SLI tag, has a feature to lock EAS. Now if you have a tag that doesn't have a feature to lock the EAS, then those tags will probably either do not respond at all, or they might respond with error. We have seen when while going through some of the documentation of ISO 15693, most of these tags of this standard, if you send them a command which is not part of their the data or the part of their command set, the tag do not respond at all. Now again, that's a very low level feature, but these reader writers can take care of that and return us an error code. So I'm going to lock it. So here again the EAS has got two more features other than lock. You can first enable the EAS or disable the EAS, and you can lock it. So there are three features here. We have seen this, how to set and reset, and assume that we have the EAS has been set and we do not want anybody to reset the EAS, so I'm going to lock it. Now lock EAS. So if you get a success message, that means this reader writer supports a command to lock EAS. Now if you try to reset, you will get error message. Now this error is the same as the 6282. So the next thing is about, okay, what happens when I, so like here there is a command. So we'll go to here. If I say read, now this read just the data, I'm going to read all. Now you can see here there is a separate command called get security status to get the value of this locked byte for a block. So likewise, the documentation speaks about getting the status, the security status of AFI, the status of DSFID and EAS. So if you try this, you get an error message. So that means this reader writer does not support getting the status of AFI. Now the question is, what do we do? Now we might end up using a direct command. Now I have not tried that yet. I'm sure Omnikey has a feature called like a session or open session, where you can send the raw commands of the tag. So we have seen this type of operations when I discussed on the ultralight C authentication, or you can probably when you're using this the DSFID tags. So probably in the later videos, once I start using this, probably we'll see how to get the status of. And keep in mind, in order to get the status of AFI, the card, this ICODE tag must support that first. If the tag itself doesn't have a command or a feature to read the AFI status, then nothing can be done. So likewise, you can't read the status of DSFID. So in other words, you just cannot find out if the DSFID is locked or not. You can find it probably by trying to set, and if you get a right error, so it means it's locked. So I think that is all about it's a very I would say it's simplified. The ICODE SLI tag is simplified because of this Omnikey 5421 reader. So in the next video I'm going to explain how to use the various commands of the Omnikey to do all the things you saw in this video.